So let's extend what we talked about yesterday. We were talking about comparing integers. We learned what integers were. We've talked about negatives, positives. And now today, we're going to extend it to something called absolute value. A couple of you think you know what absolute value is, I know. Would anyone like to take a shot at describing what you think absolute value means? Graydon? It has something to do with the relationship between the number and 0, but we would word it a little differently. Aubrey? Very good. It's the space, or we'll use the word distance. So we're talking about the distance that a number is from 0. That's our definition for absolute value. The notation for absolute value are those two vertical bars that you see. Some people mistake those for parentheses. They're not parentheses. They're telling you that they want you to measure a number's distance from 0. So it'll be a vertical bar and then a number inside of it, followed by another vertical bar, maybe, if it wants to write. There we go. Something like that. Now you have to be careful when writing these vertical bars that they don't look just like ones. Okay, this could very easily look like 131 if you don't accentuate, those bars and make them longer. So just watch for that. All right, so now if we're talking about the distance that a number is from 0, then that should mean something about the final result. We talked about this a little yesterday when we were mentioning opposites. We said 4 and -4 were opposites because they were the same distance from 0. 10 and -10, etc., etc. They're always the same distance from 0. What do you know about distance in terms of how you measure it, or the result of measuring distance? What type of number will you or should you always get? All right, I limited it to you by saying it that way. What type of number, anytime you would measure distance, should you get? Not sure? Tom? Why positive? I don't know. Does it make sense? Like if I said, when I walk to school in the morning, I walk 3/4 of a mile to school. When I go home, I live -3/4 from school, 3/4 of a mile. Does that sound right? You don't typically say it that way, right? You don't say, like, oh, I'm standing up front. I'm going to walk over here to my cabinet, which is about 10 feet away. Now I need to go back to the board. So I'm going to walk another -10 feet, and I come back to my board. You don't say it that way. No matter which direction I'm walking, it's still a positive distance. Tommy, you were right. It's a positive number. So I go 10 feet this way, 10 feet. I don't care if I'm facing backwards, if I do the moonwalk across here and come back negative, it's still a positive distance. I still covered 10 feet. Okay, just like when you walk, home, it's not a negative number because you're going a different direction. It's still a positive distance. It's like getting in your car and you drive on a trip. If you go to the beach and it's, 500 miles away or whatever, when you come home, it's not -500. It's not like, oh, canceled each other out. You guys didn't drive anywhere. Well, then why do I have all this sand in my car? Why do I have all these memories? What just happened, right? No, you went 1,000 miles. You went 500 and 500. That's the way distance is measured. One of my most appropriate analogies to this or comparisons. How many of you ever seen the movie Ferris Bueller's Day Off? You ever seen that movie? Every year it gets a little less and less and less. It's an old movie. It's from the 80s, okay? None of you guys were born in the 80s, right? All right, joke missed. All right. Clearly you were not born in the 80s, all right. But sometimes you guys tap into the old classics. Well, really quickly, Ferris Bueller is a gregarious, maybe somewhat problem child who would rather not be in school than be in school. So one day he decides he's going to skip school, okay? And he goes to his buddy's house and he borrows his old man's Ferrari as this really fancy car. He loves this car. This guy's father loves this car, I think more. He said he loves it more than he loves his son, right? So they take this car and they drive it all over Chicago all day. They have a great day. They're at the Cubs game. They're out, eating, interacting, whatever. Well, they get home at the end of the day, and they're like, uh-oh. They look at it's called the odometer that measures the miles the car has traveled, and they're like, uh-oh, he knows exactly how many miles are on this car. He's going to know that we took miles off or added miles to this car. So for those of you that have seen it, what's their brilliant idea? Do you remember what their idea was to try to help so that the father doesn't know that they used the car miles? Figure. Yeah, they raise the car up, exactly, turn it on, put it in reverse, and it's just sitting in the house, and it's just spinning in reverse, the wheels are, okay? And they think, oh, if we let it run in reverse for however many miles, it'll cancel out everything. Does it work? No, it still adds miles to it because it's still going, all right? It's measuring a distance. It doesn't matter if it's going backwards or forward, you're still going a distance, okay? So when we talk about absolute value, you're going to get a positive value. Let's jump right into these examples. The very first one here. It's kind of small on my print, but you guys can see it a little better on yours. Number 1 says the absolute value of -3. So that's what that's saying. When those 2 vertical bars are wrapped there, they want to know what is the distance from 0 that integer is. What would you tell us the answer is to number 1 then? Nolan? Yeah, it's just 3. It doesn't matter that it goes to the left, it's still 3. How about number 2? The absolute value of 12. Dominic? 12, yeah. Number 3 is a little different. Now this involves an operation. So when you do a problem like number 3, we treat the absolute values like parentheses in terms of the order in which we do them. So we would do the absolute value symbols first. Okay, so let's do that. Tell me the absolute value of -10. You guys can just say it. It's 10. So this problem becomes 10 minus, what's the absolute value of -5? 5. Our answer then would be, good, because we do 10 minus 5, and we get positive 5. That's what absolute value looks like. All right, keep moving down here. We're going to make these examples a little bit more complex. And this highlights what I just said. Absolute value brackets are grouping symbols in the order of operations, like parentheses, right? Okay. So we go to example 4. And we've been doing these evaluate problems. And we know that anytime you know the value of the variable, all you do is substitute it in and then work it out. So for example 4, this problem becomes 12 plus the absolute value of -6. So I'm just going to rewrite it. I would suggest you rewrite it too, so you can see where it started. And then what do you get when you simplify this? Absolute value brackets first. Any operations after that? What do you get, Duncan? Does this right here become 6? Is that what you're saying? Okay, so the absolute value of -6 is 6. So now we have 18, yeah. So this expression becomes 18. Okay? So we don't add 12 and -6 first because of these absolute value brackets and this concept up here that says we must do those first. So go ahead and try the next one. In fact, why don't you try the next 2, 5 and 6? And I'm just going to stop at your desk. And when you get them, let me know. See what you... After checking your work here on number 5, looks good for the most part. The only issue that I saw was that sometimes we forgot what this means when the 2 is right next to this absolute value. So this means what operation, when I highlight here, what operation is happening right there? That's not written in. We just have to know what that means. Tommy, what is that? It means multiplication. So give me the order in which you solved example 5 here. Go ahead, Tom. Absolute value of negative 3 is 3. So I have 18 minus 2, and you said this means multiplication. Okay. 6. 12. Very good. And there's your value. Good. Now let's jump down to number 7. Somebody want to take 7 for us? Go ahead, Nolan. Okay, let me just copy everything in, and then I'll let you start. Minus the absolute value of -2. Okay. All right, so did you take the absolute value of all of them first?
Yeah.
So this is 7. This is +5. And this is +2.
And then 7 times 5.
Uh-huh. Okay. Very good. First thing he did was get rid of those absolute value symbols, and then you follow your order of operations from that point on. The biggest mistake I see when we first start doing absolute values is that you have no problem seeing like a negative, like -5, and saying, what's the absolute value of -5? And you say, well, it's 5. It's 5 places away. But unfortunately, if I say, okay, well, what's the absolute value of +5? I'll get people that'll say -5. They think that you're always taking the opposite of what it is. It's not an opposite concept. It's the distance concept. Remember, distance is going to work out to be positive. That's why these are coming out to be positive. I didn't ask you to do number 7, but I know some of us tried it. That would be like a next level type problem. The correct answer on 7 should have been 8. So if you want to try number 7 on your own, go ahead. Now you know what the answer should be. See if you could work it out and get that. All right. Let's jump to the next page here. Yep. Actually, I tell you what. Hold on. What we're going to do is finish those up tomorrow.